Good morning again, everybody. It's Ryan Jenkins with Jenkins Farms. This morning I'm going to talk to you some about precision agriculture and what that means. There's a statistic that's floating around that says within the next 30 years, by the year 2050, farmers are going to have to be able to produce 70% more food and fiber to keep up with the demand of the world. You know, as a farmer, I already think we're very efficient. I think we're doing the best with what we have to do with. I think we're coming out with the best outcomes possible. Just in my almost 30 years of farming, you know, the yields that we make every year have greatly increased. So I think that this is attainable, but to do it, we're going to have to continue to become more and more efficient. And one of the ways that we do that is by using something called precision agriculture. You know, I've said that I'm doing this YouTube channel for the benefit of my friends and people all across the world that are disconnected from the farm. I believe that's a major problem these days, is that people have become very disconnected from agriculture. They don't know where their food and their fiber comes from. So for the farmers that are watching this, you might want to fast forward a little bit. I'm just going to go in depth a little bit about what we do and what precision agriculture is and how that's going to help us into the coming decades. So everybody knows what agriculture is. It's basically the art or the science of producing food and fiber to maintain equilibrium in the world, to maintain our needs. So precision agriculture, if you think about the word precision or precise, basically we take the simplest form, the simplest way to put this is, we'll take a field, and instead of it being a 100-acre field, we'll break it down into 2.5-acre fields so that we can manage those more precisely. Today I'm going to show you in just a couple of minutes, I'm going to show you some soil sample data that we've pulled and how we're using precision agriculture to make our nutrient placement more precise, to only put fertilizer where it needs to be put and not put it where it doesn't need to be put. So as I say, I'm breaking this down on simple terms for everyone. Here's how it used to go. So used to, we would take we're going to use a 100-acre field today for our example. Used to, we'd ride around with a soil probe, we'd push it down into the soil, pull out some plugs, we'd put them in a little bag, mix them all together, put them in a bag, we'd send them to the lab would send the results back to us, and it would say, all right, Mr. Jenkins, you need to put out a ton of lime to the acre. Lime is what we use to adjust the pH of the soil. So it'd say, you need to put out a ton of lime. So I would go, for all you mathematicians, I would go get 100 tons of lime, that's a ton to the acre on a 100-acre field, and I'd put it out across the whole field. Same way with my nutrient inputs. So our main nutrients that we use every year are nitrogen, phosphorus, and potassium. If you go buy a bag of fertilizer at the store, you know, it might say 10, 10, 10, or it might say 13, 13, 13, or it might say 9, 18, 6. That's what the three numbers are for. That's the percentage of that nutrient that's in the bag. So we would get our soil sample results back from the lab, and we would go put it out. It'd say, all right, usually nitrogen, you put it out during the growing season because it only lasts for a little while. The phosphorus and potassium last longer, so you could put those out ahead of time. But usually we would put the same amount. It might say you need 150 pounds of phosphorus and 200 pounds of potash across your field. So that's exactly what we would put. We'd put it on every acre of that field. All 100 acres would get treated the same. Well, along came GPS technology. All of you use it to get from point A to point B. Farmers use it to get from point A to point B on a much finer scale. The systems that we use are accurate to less than an inch 99.9% of the time, and they actually drive our equipment for us, drive our tractors for us. So we use that same technology. They decided, hey, you know, this 100-acre field doesn't have the exact same soil type from one end to the other. So they would we started breaking it down into little micro fields, if you will. Precision agriculture, precise. We'd break it down into little small fields so we could precisely take care of that amount of land. And what worked good for us was 2.5 acre grids, as we call it. We call it grid sampling now. So now we'll take the boundaries of the field, the 100-acre field, we'll put it in a computer, and it'll tell us where to go pull soil samples. It'll break it down into little 2.5 acre fields. And we'll go pull the soil samples from each of those places, and that is its own individual sample there. It will get sent to the lab. So, you might have 25 samples from a 100-acre field. We'll send it to the lab. Lab will send it back, and it'll print out on a map, and we can actually take a look at it. I'm going to show you some in just a second. Once we get that, we can make a prescription. The labs know, everyone knows the amount of nutrients it takes to produce a certain amount of yield of a certain crop. So we'll use that data, we'll plug it into our GPS system, the little prescription, we'll put it in there, and then I'm going to show you later on the equipment that we use to put these nutrients and pH adjusters out. So let me show you here. I'll flip this around. If you look here, it might be hard to see, but if you look, here is our 100-acre field. And each of these little dots is an exact soil sample. So remember, used to, we'd put out a ton of lime to the acre. Well, look right here. Here is the map. And this is the recommendations for the lime. So the biggest majority of it equals 0. There's a 1,400, a 1,400, 1,100, a 1,600, and a almost 1,400 pound where it needs to go. So if you average this out, used to, like I said, we'd have put 100 tons out on this field. Well, now this field actually only needed about almost 6 tons. So you can see how that would save money. It also levels the playing field. It makes it much more consistent going through the field, because all the places before, all these other places would have gotten way too much. They didn't need any. They would have gotten way too much. It's just like if you think about, if you got 10 people at the supper table, from kids to adults, everybody's going to eat a different amount of food. It's the same way with the crops. Depending on what soil type it is, how wet, how dry, there's 100 different variables, but that particular crop needs different amounts, even though they're all in the same field, even though they're all sitting at the same table, but each one needs a different amount. And so this helps level the playing field. Here's our phosphorus inputs. Same thing. The biggest majority of the field doesn't need any. Here's one little hot spot where it needs 124 pounds. These other spots need 100. So the average rate of this field, remember I used 150 for an example a while ago, 150 pounds per acre. So this whole field averaged out to need 37 pounds per acre. So you can see we'd have really been putting out too much in most cases. And then there's some places where we weren't putting out enough if we'd have gone with the average. So I'm going to show you in a little while the equipment that we use. Chase is going to be putting out some potash for us today. That's how we adjust our potassium level. We're increasing the potassium level in the soil. And show you some other cool things on the farm. I know you don't want to see me talk all day, but I think it's important that people see the technology that we use to make sure we're using the fewest inputs possible, putting the fewest chemicals and fertilizers into the environment, and when we are putting them, we're putting them just where they need to be put. So, hope you like what we're doing. I'm going to continue to post stuff all along. In just a second, I'm going to show you the equipment that we use and show us applying some potassium to the soil. Thanks.